In this explainer, we're going to break down application programming interfaces, or APIs. We'll kick things off with the fundamentals, but then we're diving straight into the technical mechanics. We'll cover how to connect to existing APIs and, even better, how to build your very own.
All right, let's jump in. We're going to start with the fundamentals. Then we'll dissect the mechanics of REST APIs, which are really the de facto standard. After that, it gets hands-on. First, we'll integrate a real API, then we'll build our own from scratch. And to wrap it all up, we'll explore the massive ecosystem of public APIs out there for you to use. It's a logical path from theory all the way to creation.
So, let's kick off with Section 1, APIs, the essentials. This is where we'll bridge the gap between the common analogies you might have heard and the actual technical reality.
At its core, an API is basically a standardized communication bridge. The key takeaway here is that it allows two completely separate applications to talk to each other using a predefined set of rules without either one needing to know anything about the other's internal workings. It's this standardization that really makes modern software so interconnected.
You've probably heard the classic restaurant analogy, right? You're the customer, the API is the waiter, and the kitchen is the server. You order from a menu. The waiter relays that order and brings back exactly what you asked for. It's a great starting point for understanding that basic request-response concept.
But look, we're here to go deeper than that. This explainer is for those of you who want to understand what's actually happening in that conversation between the waiter and the kitchen. We're going to examine how that order is technically structured, what language it's spoken in, and how the dish is put together when it's delivered back to the table. All right, let's get into the technical heart of this whole thing, the mechanics of REST APIs.
Now, REST isn't a protocol, it's an architectural style. Its principles, especially being stateless, which means every request is independent, make it incredibly flexible and scalable. And that's exactly why it's become the undisputed standard for building modern web APIs. It just leverages the existing infrastructure of the web itself.
Okay, this is where it gets interesting. This table shows you the core verbs of API communication, the standard HTTP methods. A GET request fetches data, like asking for the weather. POST creates something new, like a user account. PUT updates existing data. And DELETE, well, that one's pretty self-explanatory. These four actions form the foundation of most API interactions.
So, how do we actually tell the API what we want? We use an endpoint. And this right here perfectly illustrates the structure. You've got the base URL, which is the API's address. Then there's the path/weather, which specifies the resource we want. And finally, the query parameters, like q equals Zurich, which filter the request. In this case, asking specifically for the weather in Zurich. And what do we get back? Data, typically in JSON format. It's the universal language for API responses because it's lightweight, easy for both humans and machines to read, and it's supported by practically every programming language out there. The data is organized in simple key-value pairs, which makes parsing and using it in any application incredibly straightforward.
Okay, we've got the theory down. Now, in Section 3, let's get our hands dirty, connecting to an API in practice.
The process is pretty systematic. First, you find the API you need and get your credentials, usually an API key. Then, you have to read the documentation. That's non-negotiable. After that, you write the code to make the request, process the response you get back, and finally, test everything before you deploy.
So let's look at Step 3 in action. This Python code shows the core request using the requests library. But, in a real-world application, we'd make this more robust. You'd want to check the response status code. Is it a 200 OK? And you'd wrap the whole thing in a try-except block to handle any network errors or timeouts. That stuff is absolutely crucial for building stable applications.
And here's Step 4. That r.json method converts the response into a Python dictionary. Now, saving the data to a file is a great first step for analysis, but the real next step is to start traversing that data structure, maybe looping through the list of events to pull out specific information like the title or date of each one. That's the typical workflow for processing API data.
All right, now for the most creative part, Section 4, developing your own APIs. Let's look at how we can go from being a consumer to a creator using a modern framework like FastAPI.
FastAPI has exploded in popularity for a few very good reasons. It's built on modern standards like OpenAPI, which means it automatically generates interactive documentation for you. It uses Python's type hints for powerful data validation, it's incredibly fast, and it handles modern needs like asynchronous code and authentication with ease. And look how simple it is to get started.
But let's not just stop at Hello World. The real power of Fast API shines when you expand on this. Imagine a path like @app.get/items/item ID. Fast API will automatically validate that item ID and throw an error if it's not an integer. That's the built-in power of type validation with Pudentic, and it makes building robust APIs almost effortless.
Now, to bring this code to life, you just run this command in your terminal. Uvicorn is the server that runs the app. Main.app tells it to look inside the main.py file for the object named app. And that -reload flag, it's a lifesaver in development because it automatically restarts the server every time you save the file.
This quote really captures the modern philosophy perfectly. Frameworks like Fast API encourage an API-first approach. The idea is you define the structure of your API using tools like OpenAPI before you write the implementation. This acts as a contract, it ensures clarity and consistency, and it enables things like automatic documentation and testing right from the very beginning.
So, what's out there to connect to? Let's explore that in our final section, the public API ecosystem.
The sheer variety of public APIs is just staggering. You can get financial data from CoinGecko, geographical info from REST countries, access to powerful machine learning models, or, just a random picture of a dog. Whatever your project is, there's almost certainly an API out there that can provide the data or functionality you need.
A prime example is the OpenAI API. It gives you direct access to some of the most advanced AI models in the world. You can build applications that generate text, translate languages, or create images from a simple prompt, integrating cutting-edge AI with just a few lines of code.
Then on the other end of the spectrum, you have data-rich APIs like REST countries. It provides a treasure trove of structured information about every country in the world, from capitals and currencies to borders and languages. It's a perfect resource for building educational tools, travel apps, or data visualizations.
So, here's the bottom line. APIs are more than just a technical tool. They are the fundamental connective tissue of the digital world. They're the building blocks that allow developers to stand on the shoulders of giants, to enable automation, to drive innovation, and to create the complex, interconnected software of today and tomorrow.